P.7. Yesterday we solved those absolute value inequalities. Today we're going to work on the quadratic inequalities. We're going to use a couple of different methods, techniques to solve these. Okay. The first one here we're looking at, okay? Well, notice it mentions a quadratic inequality is solved by first solving the quadratic equation. So in other words, we're going to want it equal to 0 instead of the inequality symbol. So that's always going to be our start there, is that we're going to think about, okay, what is this if we would solve it as equal to 0? That's going to give us two solutions. And then we're going to use the graphing calculator to check and see which numbers are going to make this inequality true, okay, to write our less than or greater than statements. So we're going to stop, or we're going to change this here, and we're going to think about how would we solve the equation x squared minus x minus 12 equals 0. Okay, so forget the fact that it's an inequality for the moment. How do we solve this?
Factor.
I would, and here's the deal. Technically, we have multiple different methods we could go here. Probably the easiest method is going to be to factor, where we have it equal to 0. And when I say factor, what am I talking about here? Two parentheses. X squared breaks into x and x. My other numbers need to be numbers that
Add would be -1 if you multiply -12.
yes.
Yeah.
So what multiplies to be -12 and adds to be -1?
-4, +3.
-4, +3. What do I do to actually solve now? Okay. So x minus 4 equals 0, or x plus 3 equals 0. So what solutions do we have? X equals 4 and x equals -3, yes? Now, those are part of our answers, but they're not going to be the full answers we're going to give, because here's the deal. This was an inequality. I want to know when this equation is true, when instead it's an inequality. So when x squared minus x minus 12 is greater than 0. Okay? There's a couple different ways we can look at this. We're going to use the graphing calculator, okay? And we're going to think about it in that terms. So, what does greater than 0 mean on a graph? But when we're looking at the whole equation here, we don't want to think right, because I want to know when this whole equation is greater than 0. That whole equation means I want to know when y is greater than 0 and where is greater than 0. That's going to be above, right? So because this says greater than 0 here, we're going to look at the graph and we're going to ask ourselves, when is the graph above the x-axis? That's the question I'm asking myself here. So, in order to do this, we're going to look at the graph. And we're going to graph the equation y equals x squared minus x minus 12. And then we're going to find out where is the graph above the x-axis. Okay? That's what we're trying to look at here. So, write down what you need. Grab a calculator and do some graphing. At least have the basics down. We know how to graph this. This part easy peasy at least. typed it in. You are so not seeing what I'm typing. Now I'm zooming into you. There we go. Okay. Does your graph look like my graph? That's good. That's a clue that you typed it in, right? Right? Which is always a question at this point in our lives. Okay. As we look at that graph, and I'm going to sketch the graph on here, what do you notice about this graph? Okay. It's a parabola. I'm listening to you and it's throwing me off. It's a parabola. What do we notice about this parabola? Okay. Can't see the bottom, but we know what that parabola is doing, don't we? Okay. I mean, it's a right side, it's an opening up parabola, right? It's a right side up parabola. And I can pretty well guess that it's going to, you know, just look something like that, right? Now, where is it above the x-axis? What'd you say?
Negative infinity to negative 3.
Okay. So this piece is above the x-axis, yes? Is this a key x value here to notice? Negative 3, is that a surprise? No. We just solved that equation, set equal to solve it. We found our zeros. That's what that is. So one of the answers that Jaron just gave is he said negative infinity to negative 3. Because right here, where is it above the x-axis? It starts being above the x-axis way up and way left, yes? So way left means negative infinity. When does it stop being above the x-axis? Negative 3. Now, infinities always use parentheses. The negative 3, you have to consider here, it just wants to know when is the graph greater than 0. Does it want to know when it's equal to 0? No, it does not. It just wants to know when it's above 0. So are you getting where I'm leading you to here? Parenthesis or bracket? A parenthesis. Okay. A bracket here would indicate that they want to know when it's greater than or equal to 0, which is not what it asked. Okay. And you can use the word or you can use the U symbol. Obviously, I've kind of led you to believe. Where else is this graph greater than 0? Okay, it starts being greater than 0 at 4, and that's what? 4 to infinity, because it starts being positive at 4, and then as it's going up, it's moving right. And so that is 4 to infinity. Infinity, of course, uses the parenthesis. What about the 4? A parenthesis, because they only want to know when it's greater than 0, not when it's greater than or equal to 0. Okay. I also have written in on my paper, and Jaron led us to interval notation, so I went with it. And interval notation is what I'm going to be asking you to look at, right? Like that's what I want your final answer to be. We could also write this in terms of inequalities, because we could have said that this is x less than negative 3 or x greater than 4. Okay, that would have been true as well, but interval notation is really where I need you guys to be. Okay, so that's just equivalent answers. Questions? Okay. When you have those outward pieces there, it's going to be like a less than and a greater than. So it's going to be negative infinity to a number, and then a number to positive infinity. Let's try the next one. Example 4. 2x squared plus 3x less than or equal to 20. Thoughts?
Subtract the 20.
Okay. Before you can solve it by hand, before you can graph it, either way, this needs to be equal to 0. So if we subtract the 20 over, 2x squared plus 3x minus 20 is less than or equal to 0. Officially, we want to solve this by factoring. Now, officially, I'm going to make it equal to 0 first. So think as we're solving as 2x squared plus 3x minus 20 equals 0. Turn on the brains. Gonna make you work a little bit harder here. Okay. We have an a value up front. So in order to factor this, we do need to think product of AC. So product of negative 40 and a sum of positive 3. Okay. I had the 5-8 combo as well, and it was positive 8, negative 5. What do I do with the positive 8, negative 5 in this scenario?
You put them
Yeah, split that middle term. These are not going to be the places it crosses the x-axis. Okay, we got to finish solving here. Well, one of them might, I guess, but they definitely both won't be. So I'm going to carry down the 2x squared. 3x, I'm going to split it as plus 8x and minus 5x. I'm going to carry down the minus 20, and it's still equal to 0. Okay. We got 4 terms there. So we're going to split in half. GCF of the first half. 2x. When I factor out 2x, I'm left with x plus 4. GCF of the second half. Okay, minus 5. You factor out that minus 5, I'm left with x plus 4. 2 parentheses, yes. 1 parenthesis is the GCFs of 2x minus 5. The other parenthesis is the x plus 4s that are in common. Set each part equal to 0. This stuff's coming back, right? So 2x minus 5 equals 0. X plus 4 equals 0. Do the solving. What do I get as my x values? Okay. Add 5, divide by 2, you get 5 halves. Subtract 4, you get negative 4. I can skip that work, right? We got the basics here. Now, so that's why I said we don't just want that negative 5 and 8. What do we know when we look at the graph about 5 halves and negative 4? What's this going to be? 2.5 and negative 4. And on the graph, what are we going to see there? Parabola. What's the graph going to do at 2.5 and negative 4, though?
go down.
Cross the x-axis, right? Like those are going to be the places we are crossing the x-axis. Okay. And as we look at this graph, what do we want to know about this graph? That's going to be where we cross the x-axis. What do we need to think about here? This time it's where is my graph?
Or less than or equal.
Less than or equal to 0.
Oh, so down.
So now I don't want to know where is my graph above the x-axis. Now because it's less than or equal to, I want to know where is my graph below the x-axis. Okay, where's my graph below the x-axis? Okay, in order to figure that out, we're going to graph. The equation you're graphing is y equals 2x squared plus 3x minus 20. And if nothing else, folks, this is good practice graphing just because we're newer to these calculators, right? Shocker, it's a parabola, isn't it? Now, as you start to get used to these, technically we could do this without graphing it. Because we know enough about, we already know where the graph is crossing the x-axis. We found our x-intercepts or our zeros. We know if this graph is right side up or upside down, don't we? Because this is a positive x squared term, so we know it's going to be a right side up graph. So at that point, you know what's happening in that respect. Okay? Now, we're going to get somewhere you have to graph them on the calculator. Okay? Don't worry. But this is kind of a, it's kind of a middle of the road type thing here. You can do this fully on the calculator. You can do it without the calculator. If I look at this graph, yes, it goes off the screen. Could I adjust my screen and make it look better? I could, but do I really need to? To me, I have the knowledge. I have what I need. So, now the question is, where is my graph below the x-axis? What are your thoughts here?
-4, positive infinity, negative infinity, 2.5.
Say that again. I'm trying to think about something here.
Because -4, you start at -4 and you're going right, but down, so positive infinity? No.
Well, it is, okay, so when we're looking at where is the graph below the x-axis, which piece here are we looking at here? We are looking at this u here, yes? And it does start being negative at -4, yes? Now, what I'm going to disagree with is the positive infinity part. Okay, so it starts being negative at -4. Then, when does it stop being negative? 2.5. It doesn't. In other words, it doesn't go on to infinity. We have endpoints here. Okay, so, and I think what you were looking at is you were kind of thinking, okay, it's going to be x greater than -4 and x less than 2.5 is what you were kind of thinking of. But when we put that together, that's -4 less than x less than 2.5. So in interval notation, how far left does this interval go? -4. Where does it stop being negative? And that is the 2.5. Now, what I haven't addressed, parentheses or brackets. Why? Right here, there was an equal to sign, yes? So we do want to include the -4 and the 2.5, which means when I was writing these inequalities, what should I have been putting on them? All those inequalities should have had equal to's. Okay? Again, the inequality, I can't remember how the book works on this lesson. I can't remember what the directions say. I'll have to pull my answer key and double check, but I'm pretty sure I know I'm looking for interval notation. Okay, so I want you guys practicing that.
For like our tests, where you want us to
Interval notation, yeah. I mean, I'll double check that, but I'm 99% sure that that's what I'm looking for here.
Okay.
Okay. So that's good, yes?
Yes.
Okay. You've seen two different options. If it's going outwards, and you need the two pieces, you're going to have two different pieces of interval notation. If it's just one piece in between the intercepts, you're going to have one piece. Okay, pay attention to whether I want less than, so below the x-axis, or greater than, above the x-axis. Okay, ready for the next set?
Yep.
Here, notice the heading is solving quadratic inequalities graphically. Okay, if we try and solve this one non-graphically, what's the problem we run into? The last two we just factored. What are two numbers that multiply to be 1 and add to be -4?
No.
It doesn't, right? Okay, so all that's saying, it's not saying there's no answers, it's just saying that my answers aren't going to be nice, neat, whole numbers. So we are going to do this graphically, which means we're going to graph it. Obviously, make sure your inequality has a 0 on one side. And so then I'm going to be graphing y equals x squared minus 4x plus 1. You guys want a fun little tip here? I know that I have to regraph all these same things this afternoon in my afternoon class, right?
Yeah.
I'm trying to save some time, be lazy. I don't want to have to retype them this afternoon. Notice I've got all three typed here, yes? Only this bottom one's going to show up. And the reasoning is here that I can go over to this equal sign, and I can highlight it or unhighlight it. If that's highlighted, it's going to show up. These two, I've unhighlighted, so they're not going to show up. So if you ever have something, big long thing typed in, you're like, I don't want to delete that, but I want to ask Mrs. Sargent for help when I see her, you can turn that graph off. Okay, so just by doing that, and when I start typing, if I start typing in the next one, it automatically turns it on. But you can turn graphs on and off. So random little, I try and throw out random little tidbits. It's helpful at times. And keep in mind, those of you using my calculators, you're pretty much the only one that uses your calculator. Okay, unless one of my calc kids comes into a situation, and probably what I'll guide them to do is grab some of the calculators that are less likely to be used. Okay, but those of you that are exclusively using my calculators, whatever you do the day before is probably still going to be there the next day. Okay, because it's, it should be. Okay, so what do we know?
One of the x points is 0 plus 4, 2, 5, 5, and 3, 4, 8, 2.
How do you unhighlight?
You just go on the equal sign to enter. Does that make sense?
Yeah.
Sorry, I might not have specified that very well. Okay, Katie's are ballpark, but they're not precise.
We gotta do
You
that.
have to 0 it.
Okay, so Katie, will you just give me trace values?
Yeah.
Okay, so here's the deal. I need specific answers. Okay, so what Katie did, this is wrong. She gave me ballpark answers. I don't want just in the ballpark answers, okay? She traced it and she said, oh yeah, that's right around there. And then she went over and said, oh yeah, that's,
2 points. That doesn't, no. Yes.
So, okay, do you remember how to find your zeros? X-intercepts.
Yeah.
I'm going to go into my calc menu here, right? That's right underneath, that's right above trace. So I'm going to do second and my trace button. And then I'm going to go to option number 2. Now, we're going to do this 2 different times, yes? And some of you remember how to do this, right? So it's not a big deal. But some of you I know are going to be like, oh, I've already forgotten. That's why I'm here, okay? So, I'm going to pick one, and I'm going to use the one that is between 0 and 1 as my first one. It's asking left bound. So left bound is to the left of that. So in this case, left bound is above it. I'm going to hit enter. Right bound means I need to go to the right of it. So after it crosses through the x-axis, right bound happens to be below it on this one. I'm going to hit enter. Then guess. Let's go back about where it crosses the x-axis. That's my guess. I'm going to hit enter. We should all be getting the same 0 here. Exactly, yes? 0.2679492. I know it's a 0 because my y value says 0. Now, I have that to 2 decimal places. So I have that x is approximately 0.27. And you're going to repeat the process for the second one, yes? So redo the same thing. Second, trace to go into the calc menu. I want to find my other 0, so I'm going to hit 2. Now my left bound is to the left of this one that's, what is it, between 3 and 4? It's to the left of it, which in this case means it's below it. Hit enter. Now it's asking me right bound. So I'm going to go past it. I'm going to hit enter. You can see those 2 lines that are on either side of it. Guess is what it's asking me, so I'm going to go back and give a guess that it's somewhere around here. And I'm going to hit enter. And we should all have the exact same answer again, yes? 3.73205008. It says 0 there, guys. That's another way I know that that is a right answer. It says 0. So x is approximately 3.73, yes? Okay. Now, here's the deal. First of all, do I need to find, okay, here. Side note, do you need a reminder of to find x-intercepts? I'm going to put one over here just in case. We did second and the trace button, which takes me into the calc menu, right? And then we went to zeros. So that's your little reminder if you didn't remember when we walked in how to do that, right? I'm hoping before long you'll remember. It should be getting closer. Now, the question is, what is my answer? Okay. I have this graph that does something like that, right? I know that it crosses here at 0.27-ish, and it crosses here at approximately 3.73. What are we thinking here?
Negative infinity 0.27.
And then 3.7.
Okay. Because we never talked about it, but what were we being asked for? Greater than or equal to 0. So thus you're asking yourself, where is it above the x-axis? Okay. So where is it above? Those are my aboves, yes? And they are on the outside. It's to the left of 2.27 and to the right of the 3.73. Okay, so if we write it, as an inequality, it's x less than 0.27 or x greater than 3.73. Am I using equal to's on these?
Oh, yeah.
It said greater than or equal to, so I'm using equal to these. In terms of interval notation, okay, that means when it was less than 0.27, that's negative infinity to 0.27. Infinity with parentheses, 0.27 then is with a bracket. Union, or, my next interval starts at 3.73 to infinity. Okay. Questions on that one? some of your homework is going to say, I don't know if it's solve algebraically first and then, use the graphing calculator to help you. If it says to solve algebraically first or something, this is the work I should be seeing here. You should be finding these zeros with the with your brain first before you go to the calculator. If it says just solve graphically, you're going straight to the calculator. Okay? Okay, example 6. What are we going to do to start this problem? We're going to graph. What are we graphing? Okay, as long as it is already equal to 0, you're just going to graph see y equals x squared plus x plus 2.
It's no.
Okay. You have a parabola that does what? Okay, it doesn't touch the x-axis. That could be good or that could be bad. In this case,
Bad.
it's bad because what did we need to ask ourselves here?
Where does it go below the x-axis?
This was a less than 0. So that means we needed to know when does this go below the x-axis. And when does it go below the x-axis?
Never.
Never. Okay. Graph never goes below the x-axis, so this is no solution. Am I right on here? Graph never goes below x-axis, so no solution. Okay. Shall we play the what if game?
No.
I like the what if game though. Okay. What if this said greater than 0?
The whole thing. Oh, all
Would it be like negative
negative.
Okay. Negative infinity 2. If this had said greater than 0, it's all real numbers. Okay, so negative infinity and positive infinity because it's always positive. Okay? That was an easy what if game. That wasn't a bad what if game, okay?
I thought you were gonna make a song.
Yeah. I thought you were gonna put you were gonna graph it below.
So if we tried to solve this, like algebraically, is that what you're thinking?
Yeah.
I can't factor it. I'd have to go quadratic formula. And quadratic formula is going to result in a couple of imaginary solutions.
Yep. That's why I was worried.
So, I mean, we could do it. We just did this yesterday in P6, but
basically no.
I need real answers here. I don't want imaginary
I
answers for
couldn't
this.
agree more.
So, okay. One last topic, okay? Projectile motion. This is very much a mathematical related thing. It's also a physics related thing, okay?
What does this got to do with the graph?
It has to do with the graph, I promise. Okay?
We're just.
No, I promise. This, you will see the connection here.
All right.
So, given an object is launched vertically from a point, noted as S of O, feet above the ground with an initial velocity of V sub O, feet per second, the following is the equation for the position of the object t seconds after being launched. Okay, guys, think about something. Something is launched into the air. What happens?
The parabola.
Goes in there.
It goes up, it comes down, it's a parabola shape.
Good work.
Okay, so this is a parabola shape. So thus there is a connection, okay?
Was it an upside down?
Upside down parabola.
Oh my goodness.
Okay, so our projectile in our example is launched straight up from ground level with an initial velocity of 288 feet per second. When will the projectile's height above ground be 1,152 feet? And when will the projectile's height above ground be at least 1,152 feet? So, now I'm going to use all this space and then some.
4 more seconds.
So, let's go with what was shared up here in the definition. There is a basic form here, yes? S equals negative 16t squared plus V sub OT plus S sub O. or I sometimes say V naught and S naught. And realize that 0, that's just saying the initial, it's a point S of O feet above the ground, so that's its initial location. And V sub O is our initial velocity.
Why do you need the O?
That's just indicating it represents like at time 0. Okay? So, as we fill in our equation, what do we know?
The initial velocity actually is 280 feet per second.
Ah. Initial velocity, 288 feet per second. So I can fill this in for V naught, V sub O. So this is going to be plus 288 T S sub O. What's my initial location?
0
Because this starts off
at ground level.
ground level. So that says S naught is 0. So officially I can say plus 0 here, can't I?
Yay.
Now, that's the equation we're working with.
In the calculator?
Not yet. Not yet. We'll get there. Now, what does our first question ask us?
When will it be?
When will the projectile's height be above ground? When will the projectile's height above ground be 1,152 feet? So when will the height be 1,152 feet? What do I want to do with this equation?
Is our answer in seconds?
So you set it equal to 1,100.
Yeah. This right here is the, what do I want to say, the position after the object is launched. So we're going to take this equation and set it equal to that. So I'm going to say negative 16t squared plus 288t, I'm going to drop off the 0, and equals 1,152. Actually, we can do this one without the calculator now that I think about it. Okay, now, what do we need to do now?
Calculate. Yeah.
No, divide
You have to
288.
divide 288.
By it.
Oh, I didn't see this.
Square
My
root.
bad.
Both sides.
Oh.
What?
That's-
Scratch that.
No.
My face that says no.
Subtract that over and then factor. Oh.
Okay, so let's make our equation equal to 0. So we can factor it, graph it, something. So I'm going to subtract the 1152 over. So now I have negative 16t squared plus 288t minus 1,152. Now, Katie just discovered an awesome thing, and it works in homework too. These all divide by 16. Even better, divide by negative 16. You guys are on it. So we're going to divide each term by negative 16, and this problem will become 100% better. Because now we're going to end up with positive t squared minus 18t plus 72 still equals 0. Well, now this bad boy will very easily factor. T squared is t and t. Can you come up with the numbers that quickly? What multiplies to be 72 and adds to be negative 18?
Negative 6, negative
Yes.
12. Yes, Stetson.
I'll be honest, I had it wrong in my brain, so that's why I was pausing. Okay. You set these equal to 0. And we come up with solutions of, now, is it possible there's two answers?
No. I don't see it. You have to plug it in. Oh, right.
Okay, so think parabola here. It starts at 0, it goes up,
Yeah.
it comes back down. What is this saying here? where is our 1,152?
Between 6 and 12.
Here's our 1,152, right? So your item that is launched, what happens?
It hits it 2 times.
Above it between 6 and 12.
Okay, so what's happening here is at 6 seconds and 12 seconds, that's when my object hits that height. Now, officially, the first question, we have our t equals 6 and t equals 12. When will the projectile's height above ground be? So when will it equal 1,152 feet? 6 and 12, because it's on its way up at 6 seconds, and then it's on its way down at 12 seconds. So that answers the first question. The second question says, when will the projectile's height above the ground be at least 1,152 feet? What's at least? If something is at least 1,152, it is including and greater than. Okay, so greater than or equal to is what you're asking. When is it greater than 1,152 feet?
6.
Between the 6 and 12, yes? So for this piece, the second piece, I'm going to say between 6 and 12 seconds. If we use interval notation, that is 6 to 12. Since it said at least, I'm going to use brackets. Or you can say 6 less than or equal to t less than or equal to 12. Honestly, I think the answer key does more with words on this one. I can't remember exactly. Okay.
I'll write it
Did I make this make sense?
Yes.
A little bit.
Does it relate to what we're doing?
Yes.
It does.
Yes.
Okay. Your homework. Make sure you get it done for tomorrow.
Is this in the homework?
There is one like this in the homework. Either 33 and or 34. Okay. 2 through 26 evens. 33 and 34.